Hi, welcome to the video for Edexcel Physics Fast Paper Solution. This is IAL Physics Unit 3, October-November series 2016. So let's start now. Question number 1. Which of the following is an SI base unit? SI base unit, if you see volt and the coulomb, option B and option D, they are drive unit. A and C are both are base, but ampere is a base unit, current is a base quantity, and they are asking about which one is base unit. So your option is A. Question number 2. In an experiment to determine the Planck constant, a student uses light of the wavelength lambda 471 nanometer. Which of the following is the correct value of lambda minus 1? If you see this lambda minus 1, so lambda minus 1 in fact is 1 upon lambda. So what do you need to do? You just take the reciprocal for the value of the lambda. That means 1 upon lambda. Lambda is 471. And make sure that you don't forget this nano, and nano is 10 to the power minus 9. So along with 471 you put 10 to the power minus 9, and when you use your calculator you will have your answer from your calculator is 2.2 10 to the power 6. So your option is D. Question number 3, 4 and 5 refer to the experiment described below. In an experiment to determine the acceleration of free fall g, a student drops a golf ball from rest. She measures the height from which the ball falls and the time taken to reach the ground. Time taken. Which of the following equation by itself should she use? So if you see the given option, these are equations of motion, and you need to find a single equation that can be used directly. So equation 1, now see the condition. The ball is being dropped from rest. That means initial velocity for sure is 0. And we are measuring time and the height. So we should look for equation in which we can put u equal to 0, time and the height. Equation number 1, final velocity is involved that we don't know. This is not the good option. Option D, again final velocity is involved. Option C, final velocity is involved. So A, C and D are not a good option. If you see option B, that requires u, which is 0, t, we are measuring time, and acceleration we need to find, and s is the height covered by the ball. So the best option is B. Question number 4, the time she scores are 0.61, 0.63, 0.49, 0.58. Which of the following should she state as the average time? Average time or mean time? Again, you need to look for anomalous reading, and this is 0.49. Ignore this and you find the mean value or average of these three, adding these three. So 0.61 plus 0.63 plus 0.58 and divided by 3. So you will get your answer as 0.6066. You round it off, so 0.61. Option is D. Question number 5. Which of the following piece of apparatus would she not need to use in this experiment? Again, ball throwing from rest, we have a time, we have a height, and we are using equation S is equal to ut plus half at square. That means we need a stopwatch to measure the time, we need meter ruler to measure the height, we also need set square to make sure that our ruler is remains perpendicular. So we need a set square. Only thing that we don't need, or she doesn't need, is a balance, because we don't need mass, or she doesn't need a mass. So option is A. She doesn't need balance. Question number 6. A group of students is given a pack of 500 sheets of paper and asked to determine the thickness of one sheet of paper. The packet shown approximately 60 millimeter in height. Okay, outline a method to determine the thickness of one sheet of paper. You should justify the choice of instrument by reference to the uncertainties. This is a paper ream, and the best instrument for this is a vernier caliper. So we are going to use vernier caliper, or the students are going to use a vernier caliper to measure the thickness of 500 sheet, and after finding the height of the 500 sheet, they will divide the obtained height with the 500 to get the thickness of one sheet. And why are we using vernier caliper? Because vernier caliper has very small uncertainty, because its precision is 0.1 millimeter, and if you, so 0.1 millimeter is the precision, and divided by 60, it will give you a very small percentage uncertainty. That's why it is our best option or best choice to use vernier caliper. So you can reframe all these things as these. I hope you will be okay. So vernier caliper measure the total height of 500 sheet, divided by the 500, you will get thickness of one sheet. It is suitable because the precision is 0.1 and it has a small percentage uncertainty, which is 0.1 upon 60, only about 0.17%. So that's why it is a good choice. Describe how you would make the measurement as accurate as possible. It's all about measurement by an eye. So we should take care of the parallax. We should minimize the parallax error, or we try to reduce the parallax error, and we can repeat our reading from different places to find the thickness, and we use mean to get more reliable result. And because we are using vernier calipers, we also can include a zero error. So we should see for if there is a zero error in the instrument. Question number 7. A student is asked to determine the Young modulus of a nylon in the form of fishing line. He arranges the fishing line horizontally with one end over a pulley so that masses can be hung vertically from the end of the line. Describe an experiment that uses this arrangement to determine the Young modulus by a graphical method. You should draw and label a diagram of apparatus to be used. Again, this is similar to the stress strain graph or force extension graph. We have a rectangular table, and we can put a wire passes over a pulley, hanging mass, and this might be gripped with a clamp stand. So this is the diagram, and you can label it. So I will show, this is the rough sketch. So you can draw a diagram similar to this. In fact, you don't need to write these polystyrene board and mass holder with load. You just write hanging mass, meter rule, marker is important, wire. Here the diagram is showing copper wire, but make sure that you are not using copper wire. You just replace this copper wire with the nylon wire. So you must write nylon wire, and the wooden block is not necessary, but G clamp. So this diagram you can draw. Okay, so part B, list any additional measurement instrument. Again, typical question in young modulus or stress strain or force extension, they generally keep asking any additional instrument. So we use micrometer screw gauge to measure the diameter from different orientation, and we use repeated reading and these kinds of stuff. But in this question, you just, because they are asking only the name, so you just say that you are using micrometer screw gauge. And if they ask what kind of measurement, so you can include to measure the diameter. Part C, list the quantity to be measured. It's all about young modulus. So we need extension, we need diameter, and the force acting on the wire. That means mass is hanging. Extension, diameter of the wire, and the mass or the force. For two quantities, explain your choice of measuring instrument. For extension, we use you can say for extension or for the length, we are going to use meter rule because of its precision, most appropriate instrument. And for diameter, we are going to use micrometer screw gauge. For one quantity, comments on whether repeated readings are appropriate. Of course, we are measuring diameter, so we can repeat the measurement from different position and different orientation to get a better mean value or to get reliable result or reduce random error. You also can write, so we can get a reliable result. F state independent variable, so mass is independent and extension is dependent variable. Explain how a data collected will be used to determine the young modulus. Remember, what are we doing? We are measuring mass and the extension. So the idea is this mass is going to multiply with the 9.81, so we can get force. So this is equal to the force, and then the measured diameter, we can find the area using pi d square by 4. So we have force and area, so we can find stress. And then we have extension, we are measuring extension, we would have original length, so we can find the strain after dividing extension with the length, and then we are going to plot the graph between a stress and a strain, and then we have a straight line. From the straight line, if you calculate the gradient, then gradient will give you young modulus. So you can reframe all points in your own sentences. Sources of uncertainty, removing parallax error, and because the diameter is small, so we can have a large uncertainty because of this small measurement. Comments on safety, we have hanging weight, so we should be careful about, and we put some foam underneath, and we might, because we have a wire in tension, so there is a chance that the wire breaks, so we must wear goggles. So these 2 points you can include in a comments on safety. Question number 8. When zinc and copper electrodes are put into a lemon, the lemon can be used as an electric cell. This is the lemon and zinc and copper. Okay. In an experiment to determine the EMF and internal resistance of a battery made from 3 lemon cells. 3 lemon cells. Okay. A student measures the current I for different potential differences. V. Her results are shown below. I showed the table here. So this is the table. Criticize the result. Again, if you see, a student is using inconsistent significant figure and less number of reading, unequal interval, less number of observations. So there are many points you can write for this investigation, but I'm writing these 3. So less number of readings. So we have 1, 2, 3, 4, 5 values. No repeated values are shown. Inconsistent significant figures, and of course unequal interval for voltage or current, whatever is being changed first. The equation used for this experiment is E equal V plus IR. Explain why a graph of V on the y-axis against I on the x-axis is a straight line with a gradient of minus R and an intercept of the y-axis of E or EMF. So if you see this equation, we can rewrite this equation and in the form of y equal mx plus c, because this is an equation of a straight line in which coefficient of x is a gradient and the constant term is a y-intercept. So you need to rearrange this equation in the form of this. So what is the arrangement of this equation? This is equal sign. On the left hand side, we must have dependent variable, and then after equal sign we must have independent variable with some coefficient. This coefficient of independent variable is a gradient, and if we have some constant, this is called y-intercepts. If you see this equation, this V is dependent and I is independent, R is the coefficient, and this E or EMF should be the constant term. So you rearrange this equation in the form of y equal to mx plus c. So you can rewrite this equation as V equal minus IR plus E or epsilon. Moreover, V is equal to minus Ri. Instead of IR, I am writing minus Ri, so I can compare easily. So plus epsilon. So you can see that this is y equal mx plus c. So here m is minus r, this is minus r, and c, which is y-intercept, is epsilon. That's why the graph between v and I is a straight line with the negative gradient, and c is intercept or e. Use these results to plot the graph on the grid provided and draw a line of best fit. So this is the table. You need to plot the graph. These are the values. So V must be on y-axis, I on the x-axis. So this is V in voltage, this is I in microampere, and this is the suitable scale. Remember, you need to choose a scale so that your graph covers more than 50% area. So if you plot this for corresponding value 117.6 and 98.89, 66.7, 1.31, 48.3, 1.6, 41, 1.7, then you have these points. And the line of best fit is this. Part D, I use your graph to determine the EMF and internal resistance of the battery. So EMF is y-intercept and internal resistance is the gradient of the graph. So how do we do that? We extrapolate this line in a backward direction and we see where the line is intersecting the y-axis, and we read this value. This value will give you value of E or EMF, and then we choose 2 points on our line, any two suitable point, and then we find gradient rise over run, and it will give us the internal resistance. So that's how we do that. We extrapolate the line like this. If you see this value, so the value of EMF from here, E, will be around 2 point, so 1.8, this is 2.2, okay, this is 2.13 something, 2.15, so 2.15, some values there. And then for 2 points I'm choosing these 2 points, and the coordinate of these points is 10, 2.2 and 110.7, and finally you find the gradient is y2 minus y1, so 2.2 minus 0.7 divided by 10 minus 110. If you solve this, your gradient would be equal to 1.5 into 10 to the power 4 ohm. Remember, I did it directly, but please don't forget the mu. Remember, there is a mu. Mu means it is a micro, so its current is not in ampere, this is in microampere. So micro means 10 to the power minus 6. So you must include 10 to the power minus 6, so you can get these values. So this is the gradient of the graph and internal resistance. So internal resistance, and this gradient will be of course a negative value because of the negative gradient. So gradient is equal to minus R. That means minus 1.5 into 10 to the power 4 ohm equal to minus R. So minus minus gets cancelled. So internal resistance 1.5 into 10 to the power 4 ohm. The battery is made from 3 lemon cells connected in series. State how you would use your answer to DI to determine the EMF in internal resistance of one cell. So the EMF and internal resistance we found in the previous part is for 3 cells, of course. So we divide these values by 3 to get the values for one cell. That's it. Thank you very much. I hope you enjoyed. Have a nice time.